While there are many misconceptions about the CERN's LHC, in this video we will review the most popular one, namely, mini black holes created by the Large Hadron Collider will end the world. Let's quickly review some basic concepts about LHC before we examine the misconception. The Large Hadron Collider, LHC, is currently the world's largest and most powerful particle accelerator. It was mainly designed to find out exactly how particles got their masses. Hadron is the name given to all strongly interacting particles like protons and mesons that are made of quarks. Two beams of hadrons, protons since they are the easiest type of hadron to work with, are steered by magnets around a roughly circular tunnel in opposite directions. At certain points around the circle, the beams will be steered into each other so that the protons can collide. Now let's hear Professor John Turning speak about this misconception.
When the Large Hadron Collider first turned on, some people were very worried that producing microscopic black holes would destroy the Earth. Microscopic holes sank down to the center of the Earth and gradually gobbled up all the matter in the Earth. That would be a big problem. Our calculations showed that black holes wouldn't actually do that. Microscopic black holes tend to evaporate almost instantaneously. But even if our theory calculations were wrong, we knew from nature's own experiments that things like that don't really happen. That's because cosmic rays coming from outer space hit the Earth all the time. They can do so with much more energy than we can produce at the Large Hadron Collider. And so those experiments have been done over the history of the Earth for 4 billion years with more energy than the Large Hadron Collider produces. And it's been done on the moon and the sun and all the distant stars. And there's never been a sign that a black hole swallowed any of these things. So we were pretty confident that nothing like that would happen during the Large Hadron Collider run. And as we've seen, the Large Hadron Collider did turn on and nothing horrific happened as we expected. And we can do that at the Large Hadron Collider, which is on the French-Swiss border. It is 5 miles across. It's a tunnel underground with a beam pipe inside and various detectors arrayed around it. This is part of the detector that was being constructed. Davis works on this experiment. It's called CMS. The C is for compact. This is the small detector. So you can see from this two things. We need lots of energy because Einstein told us we want to make new particles. The amount of energy we need is the mass of the new particles times the speed of light squared. That's a very big number typically, so we need a lot of energy. And then there's the politician's equation that lots of energy costs lots of dollars. Unfortunately, the Europeans paid for most of the Large Hadron Collider. We just kicked it a little bit. So we're getting a good deal. Here's the other main detector. It's called Atlas. It's the bigger one. So here's a human for reference. So this is about the size of a 4-story building. This is before all the parts were put in. So this is basically a giant camera for recording what happens when two protons collide at these enormous energies. So we can learn about things like the structure of electrons, if there is any, or finding particles. Okay, so here's our first headline. It's talking about the Large Hadron Collider. It's from a respectable news source. And it says, worst case, collider spawns planet-devouring black hole. So when the Large Hadron Collider first turned on, some people were very upset because they were convinced the Large Hadron Collider was going to destroy the Earth by producing a mini black hole, which then would fall to the center of the Earth and gradually eat up the entire Earth. And, well, as you know, that didn't happen. But why was it that physicists were not worried about that? So let's go back and see what goes on inside the Large Hadron Collider. So first of all, we're colliding protons, which I'm showing these little balls here. We collide them together at very high energies, and we produce a whole bunch of new particles, given all that energy that's available. So you can see sprays of particles coming out. Here's an actual event from the Atlas experiment. Inside here we see these lines. These are lines that correspond to charged particles. The charged particles move through this part of the detector. They can track those and make these lines. The outer part registers the positive. So even though there's some lines going up this way, there's very little energy being used up here. But there's a whole bunch Now, the same kind of experiment is done all the time without us, because cosmic rays come in from outer space and hit the atmosphere. This is obviously an artist's impression of what that looks like. Something like that. That's a great picture. But particles do come in at enormous energies, hit some atom in the atmosphere, and make a giant shower of particles, which can be tracked. Now, if you look at the energies that those particles have, they go up to very, very high energies, much higher energies than we can ever produce at the Large Hadron Collider. And there's a lot of them, although there's many more, orders of magnitude more at low energies compared to high energies. So at very high energies, there's one particle per square kilometer, very large area per year. And at low energies, there's one particle per square meter per second. So there's lots of cosmic rays going through you right now, but they're mostly these low energy ones. Now, we take all the events that happen at the LHC and spread them over the surface of the Earth, just for comparison. Then the LHC would sit about here on this plot. So it's not at the highest energy. It's got a slightly higher rate for cosmic rays at the same energy. But we're running the LHC for 10 or 20 years. Cosmic rays have been hitting the Earth for 4 billion years. So if anything bad is going to happen at the LHC, it should have already happened a long time ago from cosmic rays at the Earth. Cosmic rays are also hitting the moon, they're hitting the sun, they're hitting distant stars. So this experiment has been done many, many, many times, and we've never seen any negative catastrophic consequences. So that's roughly the logic that convinced physicists that they were not killing themselves by turning on the LHC.